Hello everyone and welcome to another daily math puzzle. So firstly let me go over the solution to the last puzzle. That was basically in two parts. One part was to show that there is no polyhedron which has 7 edges, and the other part was to say that for any number m bigger than 7 you can find a polyhedron that has m edges. So if you don't want to see the answer yet, pause the video and give it some more thought, because here comes the solution. I will get it the right way around one of these days. Right then, so firstly let's have a look at why there is no polyhedron which has exactly 7 edges. Firstly, let's get the camera lined up. Okay, so consider the tetrahedron. That's the simplest polyhedron, and that has 6 edges. Okay, so the tetrahedron, it has 6 edges, and it has 4 vertices. Now, the key to this argument is to consider what I would call the degree of the different vertices on the polyhedron. So I haven't written it in that way here, but let's say that the degree of a vertex is the number of edges which it's touching. So for example, in a tetrahedron, the degree of each vertex is 3. Now, what we can do then is we can add up the degree of all of the vertices on our polyhedron. So we're looking at every vertex and asking how many edges are touching this vertex. And if we do that, then we're going to effectively count every edge twice, because if this edge is here, we're going to count it once when we look at this vertex and once when we look at this vertex. So when we do this, we're going to be able to calculate how many edges our polyhedron has. Now, let's consider a polyhedron that has at least 5 vertices. Well, each of those vertices is going to have a degree of at least 3, because every vertex of a polyhedron has to have at least 3 edges touching it. So that means there has to be at least 5 times 3 divided by 2 edges by this counting method. So every polyhedron with at least 5 vertices, in other words, every polyhedron except the tetrahedron, has at least 5 times 3 divided by 2 equals 7.5 edges. So there's no polyhedron with 7 edges, because the only one that isn't like this is the tetrahedron, which has 6 edges. So there we have it. Now the other part is perhaps a bit easier if you've got the right kind of construction idea, and that's to show that for every number m bigger than 7 we can find a polyhedron which has that many edges, m edges. So one rather neat way of doing it is with what I'm going to call an n-gon pyramid, which is basically where you get an n-sided polygon, could be a regular polygon, whatever, and then we just add an extra vertex above it and connect it by an edge to each of the vertices of the n-gon. So that'll give you a polyhedron which has 2n edges. And so this works for every number n bigger than 3. And so by constructing these so-called n-gon pyramids, we get polyhedra which have 8 edges, 10 edges, 12 edges, and so on. All of the even numbers greater than or equal to 8. Now what we can also do is we can take such n-gon pyramids and we can add a fold on the base. So we can fold it across one of the triangles, as is shown here. And effectively we're adding an extra edge at the bottom of the thing. So an n-gon pyramid plus a fold, that has 2n plus 1 edges. And so that allows us to construct polyhedra with 9 edges, 11 edges, 13 edges, and so on. So that completes this one. There's probably quite a few other ways to do it. I'd be interested to see any other solutions that you folks have come up with, especially for this first part. Okay, so here's the problem for today. Again, it's one to do with integer valued equations. So we'll suppose that a and b are integers, and the question is, when can the expression a divided by b plus b divided by a be an integer? Okay, so I would like to know when, if at all, this can be an integer. What are the conditions for it to be an integer, if there are any? And how do you justify that? So, good luck. So, for example, when a equals 1 and b equals 3, 1 divided by 3 plus 3 divided by 1 is not an integer. But are there any integers a and b, which make this thing into an integer valued thing? So, good luck with that. I'll give you the answer soon.